Okay. While we're waiting for the tea to get ready, I will post a tweeter about part 1 of this series. Okay. I've posted the part 1 of the Treemap Viewer videos. Sounds like the water is boiling. All right, we're going to have to remember to milk the tea in a minute. Yes. Okay, welcome back, everybody. We are on part 3 of programming this thing. Check my camera. Oh, it's a little bit tilted. So, as soon as I got off the video from part 2, I knew what the bug was. I'll show you where we left off. So we were running our tree map thing and it looks kind of fine, but a bunch of these squares are background squares, as you can tell if you hover over them or look at them very carefully, which means we're not covering the space correctly. But I know why, and I'll explain why in a minute. But first, let's make it more obvious what's background and what's foreground so that we don't have to like squint and we don't get prematurely excited about it being correct when it's not. And the way we're going to do that is just, here's our draw loop. We're iterating over the nodes. If it's a background square, which means it has children, it's not a leaf node, we'll just draw it in like nearly black, right? And that way we can tell very easily. So if node.children, we do one thing, else we just do this. And what's that thing? We'll just, this is temporary, right? So let's call these D because they're next to C, right? D0, D1, D2, D3. This is spicy because I just rewrote compound declarations, so this might not work. Let's say K is 0.08, right? So we're just going to multiply those. Node.children, oh, node.children. Well, all right, so there we go. That's actually not as bad as I thought, if I'm being honest. But we could do better. Okay, so let's make this, it doesn't need to be that dark. All right, so it's kind of obvious it ain't totally working. But there's a reason why it ain't totally working. At least one. There's probably more than one, come to think of it, because this output does not look like what I would expect. But okay, you know, sometimes there's bugs in the program, sometimes there's bugs in what you're fundamentally trying to do. And in my mind, early on, I was like, okay, it's about filling a column and then filling a row and then filling a column. And filling a column, you determine the width of the column and then go up. That doesn't make sense. The reason it doesn't make sense is because the width of the column, the reason you fill out the full rectangle in the end is because the area that you're filling out is proportional to the size of all the members inside. So if you pick the size for the first guy and you don't let it grow for the second guy, it's not right. And so what I was doing here is, you know, in the first iteration, I'm picking this size, and then it's staying, either the width or the height is staying fixed. For the entire time. And that is not what we want. Okay, how many minutes in are we? We'll give the tea another minute or two. I think we've got some background noise. Okay, so here's the thing. We want to compute the width and the height of each of the area each time around. And that affects like all this stuff. So really, that whole thing about having root size, this is just giving me a headache looking at this. Where there's all sorts of ways that we could probably simplify it, by the way. So instead of having if horizontal else all over the place, we could probably, if we want to go the other way, we could probably just transpose the input, do the operation, and then transpose it on the way out, and it would even be faster, right? But not yet. Not yet. I would rather make it work first. So here's the thing. Every time around, we do want to know the root weight. Okay? I'm going to err on the side of sort of rewriting it. We have remaining weight. Yeah, I guess we don't subtract off remaining weight till we commit. So right. Okay, yeah, all this stuff is kind of wrong. Okay, so we're gonna go, we need two fractions here. We need this one, because this one gives us the y, or x. It's confusing, right? But if we're doing horizontal, this one gives us the y. So we're gonna go single fraction and group fraction. Group fraction is this if x, all right? So, but not child.size, it's new fill weight. We might call this proposed fill weight. Different denominator, that's going to be confusing. You know what? We could just be schmancy. Like, let's just do that. Okay, so we got a group fraction. We got a single fraction. Now, I'm going to break this into two totally different frickin' things, because here we go. We're going to have root size. Okay. Corner doesn't change, but root size does. So we're going to go, this is going to be silly for a little bit. All right, size.y equals group fraction times root size.y. All right, and this is going to be size.x is group fraction times root size.x. And this is going to be size.y is root size.y. Okay, so we're adjusting this region. Now here's the thing. I think we want to do this every time, right? Because down at the bottom, we want to use this group fraction. Well, I don't know what we want to do down at we don't really want to do anything down at the bottom. I don't know. Anyway, we set size, and then here we can combine these if statements in a little bit if we want to, right? But for now, we're just going to leave them separate. This is about the width and height of the chunk, right? And this is about the width and height of the group, okay? And so we still have this old aspect variable. Which I think we actually leave. Okay, hold on. We don't need to do anything special for the first guy now. So this whole thing might simplify, right? Because here the group fraction is going to be what we want, and the single fraction is going to be 1. Okay? And so this is just going to come out right. And so we're going to have old aspect is infinity. We're going to infinity and beyond. Okay? Which means we never will do this the first time. We set old aspect as new aspect. Here, we didn't reset old aspect here, I don't think. Well. Okay. So down here, Let me get my tea before it's gone. Okay, this stream is now T powered. Now, I think we can get rid of the first, okay, which will make me feel good. And then we extent all this. And then down here, do I have the declaration? No, first. First, boy, we're gonna have to clear out all these variables. So, now in here, when we don't like the shape, we're gonna say previous size. Just so that we don't have to recompute it. We're going to say previous size equals size. Right? So that now I mean, we could recompute. It's trivial to recompute. Maybe we should. It's potential for another bug either way. Okay. So for fraction, we go up in y. Okay. Okay. So new fill weight is fill weight total, which is 0. We add child size. So we don't actually want to do any of this. So where does old aspect happen here? We want to say old aspect is updated right here. Wait, that's new aspect. Same. Okay, so the thing that we're missing then is just this part, right? About free corner. Except we don't even need those variables. We'll keep them for a second in case we need them. But what we want to do is when we reset and we're going the other way, we now want to say, because we have root size, right? I guess we keep root corner. as well. There's just so many variables that need to get deleted and replaced. Okay, so you know, if you just think about the first step, you have the size that you chose, and you know the root size, and so it's the rest, right? You would say, I don't know if we're going to call it root size, but you would say the following. Instead of size equals free size, you would say free size, I don't know, free size dot x equals root size dot x. Well, free size, I mean, the y should be equal in either direction. Okay, it's a little bit, you again want to do a horizontal vertical. All right, so if horizontal, I think you want to do this, right? You'll say the free size dot x equals root size dot x minus size dot x, and free size dot y is root size dot y, right? You're keeping it, right? And then here you say the opposite, right? Root size dot y minus size dot y, free size dot x is root size dot x. Okay, but now I kind of want to sub in, this is the new root-ish. It's not really the root thing, right? Let's delete these stragglers. But basically, and then do we need these root corners as opposed to corner? Probably not. Again, this is just like me being messy conceptually. Right? Here we're going in X by the same amount that we're shrinking, right? Here we're going in Y by the same amount that we're shrinking. Okay. This loop is still huge. We deleted stuff and it's still huge. We're going to delete more things. I mean, there's definitely some stuff to just make this trivially shorter. Let's just fix compile errors. Okay, we renamed fractions, remember that? Frog fractions. Single fraction. Single fraction. Free corner, that's no longer a thing. This is root corner, which is the same as corner. We've got too many variables. It's fine though. I think it's probably not fine. It's probably introducing bugs. Okay, not going to work. Well, you know, we got one rectangle. That's great. Okay, so here's what I want to do. Since this thing is the big complex holio, I want to reverse this if condition. We certainly don't need that continue otherwise. I want to say if new aspect is less than or equal to old aspect, because this is just like, that's easy to see. And then this blob holio is the complex part to see. All right. Okay, now let's actually put these together because we're committed. Okay, so we're taking root size, we're resizing it for our proposed situation. And honestly, we don't need this size here necessarily, except, yeah, we don't even, well, we use it down here, I guess. Wait. Okay, the horizontal equals not horizontal. You know what? Lol, we toggled that before doing the checking of what we were doing. Okay, well that's some interpretive art. That's pretty great. All right, we're just going to step. We're going to dubstep. Okay, boom, 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 boom. Okay. Single fraction should be 1. Group fraction should be 0.54. Whoa. Wait. Fill, weight, total, 0. That's expected. Child size, killed. Okay, that sounds about right. Remaining weight. I don't remember that being so big. Maybe this was... Maybe we have different data now for some reason. So new fill weight should be the same as child size. Okay. So group fraction looks correct given these numbers. It's just these aren't the numbers I remember. So size.x is going to be, you know, some pixels. We can simplify out a bunch of this, right? Because new aspect like the fractions are always less than 1, right? So here the width is going down. Oh, I don't know. I don't want to jump to conclusions, but it sort of seems like you don't need all these variables. Okay? New width, new height. That all sounds fine. New aspect. 2. 2. Fill weight total. Okay, old aspect. 2. Previous size. Oh. Remember, I saved previous size, but when we back out from the shape, we're not using it. So that's probably far from our only mistake. It's a little bit less modern art now. All right, we certainly have a lot of thin rectangles. All right. Boom. This all seems fine. Child size. I should call size like rect or something, right? Or we should just use a rect struct instead of corner and size, honestly. Okay, fill weight. It's just better. Okay. New width, 732. Wait. Oh yeah, we're still horizontal. So group fraction is 0.42. Single fraction is 0.46. Okay, those both make sense to me. Now, because you don't actually need to compute this width and height because you're just dividing them anyway. So, you know, like, you could just combine, you could cross combine these terms. That's all. But we don't want to do that till we make sure we're right. New aspect, 175. Okay, so that's good. So far our size is 732. Okay, that's pretty okay. Group fraction, single fraction. Yeah, so single fraction will continue to go down because these are sorted highest to smallest, right? So single fraction is monotonically decreasing. Group fraction is monotonically increasing. Which is interesting to think about. And okay, size. Yeah, we don't really need like, okay, wait, if we have root size and we're computing size each time, yeah, this should basically just be a local variable right here. But again, let's figure out the problem. So we have a new width, 941. Okay, I guess that makes sense. Like I said, it's getting wider every time. That was the bug with the old thing, is it wasn't doing that. So the new aspect is 4. And that's no good. So size, we tried to go bigger. We didn't like that. Oh, you know what? You know what the problem is? Do you know what your problem is? So the problem is, because we don't have a go-to, I think we could just subtract 1 from child index. The problem is, at least one of the problems is, okay, let's see this. Corner cursor. So we go from 0 to 470. 0 to 888, that's correct. Okay, remaining weight. Free size is root size minus size.x. That's fine because now this is previous size. Root corner. So root corner is this. Free size is this. Seems right. Root size is free size, old aspect. Okay, so we skipped one of the children, which is a problem. And that's actually bad because it's going to make the weights come out wrong. Also, there's a few, okay. There's just too many variables, guys. I'm embarrassed that I'm streaming this because it's interesting because I'm making it harder than it needs to be by a lot, and I can tell that. But at the same time, it's a mildly intricate problem to be. Remember how easy this was? It's a mildly intricate problem to be thinking your way through. It'll boil down to something much simpler than what we have, but we have to get there. Okay, so few things wrong. Few things wrong. Let's say size is root size. Previous size is root size. And then let's just do, because fill weight total. See, if we didn't like the shape, we can just initialize it to the thing, right? So we have fill weight total. And old aspect. Instead of that, we'll set it to here we might end up dividing by 0. Because when we finish, we'll check this out later. All right. Divides by 0, my mans. Okay, it's looking a little bit more plausible. We're still, somehow this first area that we're allocating, when we recurse down to the wild childs, we're not setting that correctly. That is very sus, because that's the first thing that we're computing. Okay, we don't need this depth anymore, by the way. Let's get rid of that. Johnny depth. Johnny depth. Okay, so we didn't subtract from remaining weight, by the way. So this is a little bit of a, the reason I liked structuring it the other way was this is a little bit of a hack. But if the amount of code down here is simple enough, it's not too bad, as long as we don't spend a million years trying to get there. So, I mean, I don't know where all the files went. Sure seems like they mostly disappeared. Okay, let's just simplify for a minute. Okay, so we have this root size and root corner and corner, right? So root size. These are all confusing a little bit. But maybe not. So corner cursor is root corner. So let's just so fill aspect is no longer a thing. Oh, right, there's horizontal or vertical that we choose initially. So we're going to get rid of these variables. All right. Where's that? Oh yeah. I can't. Yeah. Let's move this down. Old aspect, we almost might as well just compute every, okay, we didn't change anything that time, I don't think, which is fine. Bro, so many problems. New fill weight total plus child size. Group fraction is that divided by remaining weight, which we're going to call this root weight, because it does change as we go. But we're going to call it that, because so does the root corner and etc. Oh, wait, we don't want to we don't want to subtract it here. We don't subtract it here till we actually do the commit. I don't like this. We're going to reverse the polarity of the neutron flow here. Even though it's more indent, we're going to be an indentured servant. Wait, it's here. And maybe we're going to do this. The reason we were doing it this way Wait. Yeah, it still looks the same. So we were like falling through, and the reason I want to fall through is because we do this commit and then we do this, right? Too many size variables, guys. I mean, this is a little bit silly now. Let's just do this again. So fill weight total is child.size. That might have been the mistake, or one of the many mistakes, right? We don't delete that from root weight. Fill weight total, old aspect, and previous size equals size. Okay? I mean, okay. That's even worse. Oh my God. Okay, we're going to keep going. We're going to simplify. You know what we could do? Let's just look at the top level only, right? It's going to be drawn in dark colors. Oh. Why? Oh, because when we draw, we didn't set the node. We didn't set the node. It still didn't work. Do I want to look into this? Node.node.children. Oh, because we need to say, yeah. We would need to initialize the node for each of, because we're not going into the children, we're not initializing it. Yeah. I'm not going to worry about it. Okay. So I kind of want to just make this a rect, because talking about the size and the corner separately is a little bit of a hassle. Let's try to get rid of previous size first. previous size. Okay, here, the reason we need to assign this back and have a previous size is because we're not saying new size, right? And then here we're going to call this sub width and sub height because it's for the sub rectangle. All right. Here we go. And then, okay. So we have new size. Let's do this. Just to show that only one dimension is changing. All right. And yes. Okay, so now here we don't need to say size equals previous size because we didn't set it. Okay. Okay, otherwise, here we say size equals new size. Although, yeah, that's fine. We could just recompute that on demand. Getting rid of previous size, we don't like it. All right, so that was a little bit of a win. It's not going to change anything if I did it right. Yeah. Okay. So size equals root size is not correct. It's not correct. I don't remember if I can do this. It's my own programming language. I think I can just revisit the same child by decrementing child index. That's what I really want to do. All right. So like all this stuff about then size equals root size would be right. And then old aspect. We're going back to this strat. Okay. We're just initting these to the same thing when we do it over. I'm just going to go log repeat. I'm going to make sure this works. Right? Well, we're back to this one, sort of, which is, this is obviously broken because it's like alternating in this extreme aspect ratio. But that gives us a clue. Okay, so after we say repeat, we are indeed going back to the same node. So that's good. So that actually solves our issue. I actually want to go back to this. This less than or equal to. I want to continue. There we go. And then if we don't like the shape, we do this. Okay. So root size, old aspect. Do we ever set this index? Oh no, because we have the bucket located. That's what we're doing. Yeah. I was like, wait, I don't remember setting that integer index that we added because we removed it again. Okay. We're getting more correct again. Now, okay, by the way, all this crap is wrong now. So this should be using new size, by the way. That's the whole point, is that we're sizing in one direction and then sizing in the other direction. Now we happen to know that this is that, right? Whatevs. Okay, now we're infinite looping. That's great. Oh, you know what we don't do? I realized one bug. We might have been correct at some point except for this one bug. The whole way that this works is to go and then flush. Okay? But we only flush if we exceed the aspect ratio. So if we hit the end and we're happy with the aspect ratio, we don't flush and we don't put any rectangles. Right? This flush down here. This whole thing doesn't run if we run out of children, but we're happy with the aspect ratio. Remember before how it was mostly right, but with a few holes? That was probably the issue. Now we have to know why it infinite loops. Sag. Okay, wait. We went straight into the flush. That's not good. What? Oh, because I put the breakpoint there because we moved around. Okay. Okay. So new size. Okay, we're proposing 732. Okay. So new aspect we don't like, we're 4. Okay. We're doing this. Root weight should still be well above 0, right? Yeah, that's well above 0. Unsized cursor is child index. Free size. Root corner. Okay, so Free Willy. Root corner. So that's right, it looks like. We toggle horizontal. Fill weight total is 0. Old aspect is infinity. Revisit this child. So new fill weight is child size, that's fine. Group fraction, single fraction, 1, that's correct. Sub width, sub height, new size, sub width, sub height. I mean, it just should be the same dimensions because single fraction is 1, right? So new aspect is 5. That's less than infinity. Is that, we got left with an aspect ratio 5 region? Kind of sucks. But we should have someone else to pack into it to improve that. Yeah, 995 by 186. Wait. This is not right. How did we end up with 186? Because we should be at horizontal is false now, which means our y should be the same. Our x should have shrunk on root size. Hold on. Oh, right. Okay. Yeah. No, it's fine. That's correct. We're picking 186 for the current rectangle. All right. New aspect. 1.3, much better. Continue. New aspect. Not good. So we flush these guys. Okay. Root weight still has some. I mean, we're really getting down. Okay. Okay, so now root corner, let's take a look at this. Root corner, root size. So these add up to the top right corner of the screen, which is correct. So maybe I just let it run for a while and figure out why it infinite loops. All right, it's going, it's going, it's going. Why are we looping? Wait, we're at the top level still. I expected us to have recursed into some children at some point. Okay, child index is 45. Root children is 48. Okay, so did we run out of root weight? What's going on? Root weight. Yeah. So is that because the last 3 are 0 in size, or did we goof? Let's find out. Child size 0. Okay, so we have some empty folders with 0 size files in them. That's fine. Okay, so our new aspect is going to be infinity, right? Yeah, that's no good. That's no good. This is not a very good solution, but we're just going to do it for now. Okay. Remember what I said about it looked mostly fine except for the flushing? That kind of seems like what this is to me now. This looks like kind of a correct result. It's just got holes in it, just like we had toward the beginning of the stream. But maybe our code now is a little bit cleaner. So now, how do we flush without making a big production out of this, right? So what happens is, let's verify. So if we get to the bottom, right? It's going to be almost always true. We're guaranteed actually to have a hole of at least one. Okay. Okay. So do I factor this out into a function, or is there something lazy I could do where we say flush nodes from unsized cursor to unsized cursor, display, tree map, display, fill weight total, and root weight. What a butt pain. What a butt pain. What a butt pain. This is where, like, if you have closures, you just, like, eat every variable in the universe. The thing is, we don't actually need all of these, because all we really need to do, like the root weight, and the corner cursor. Okay, actually, before we do this, let's simplify some more, right? Because oh no, we want the corner cursor. Let's just eat the pain and factor it, because you know what? This will be more readable even before we fix the bug if we factor it. So I'm just going to do this. I don't know. We might need some more. I guarantee we need some more, actually. So flush nodes. Children is an array of tree map node, unsized cursors an int, tree map is a tree map, display is a tree map display. Root corner is a vector2. Fill weight totals a float. And let's actually return this. It's a float. We're going to return new corner, new size, vector2, new root weight float. What a giant butt pain. Oh my God, Emacs, what are you doing to me? Emacs, we're just going to do this. All right. Boom. Okay. We're going to flush the nodes, and we're going to say, actually, we don't need to return the corner cursor. Oh, it wasn't as bad as I thought, because down here, see all this down here we don't need to do when we flush later, because we're done. So, so here, so we're going to pass that in. We're going to get that out. Going to put that in there, because why not? I don't know. Okay, child index -1. Right, so flush nodes here, child index. All right, root dot children. This is just children. And c dot size. Root weight. Wait, what? Oh, this must have been a float 64. Yes, it was. 192. Okay, horizontal. Oh. Oh. Size. Attempt to use a variable from an outer stack frame. Just do it. Just do it. This is one of those days when I'm like, maybe I should have implemented closures already. I'm actually not sure about that, but you should at least have that thought at times like this. Fill weight total, root weight. Fill weight total, float 64. All right. Okay. We still have the holes, right? But that's fine because we haven't added another flush yet. Okay. So we're going to do that. Okay, if we get down to the bottom, we're going to go flush nodes. Root.children.count, and hopefully the rest of this makes sense. I don't know. Oh, well, we got to put the flush nodes in the basket. So what I was saying about this getting more readable is that shortens that down. And this goes there, maybe. Hey, everybody. Remember my theory about not flushing the streams? Look at that. Okay. Okay, now I want to take the W for this so that we have a checkpoint that pretty much works. There's some things in here a little dubious, like that looks kind of skinny. I'm not sure if that's the same rectangle. I don't know what's going on. When we implement zooming, we'll be able to go in there and check it out. Okay. But this looks pretty good, if I'm being honest. Okay, now okay, did we add the files? Maybe. Treemap progress. It's like Pilgrim's Progress, but with a tree map. Okay, so now we can mess anything up and it's saved. There's a bunch of things I want to simplify here. Like I said, I think we can boil this down to substantially less code. By the way, the display has a pointer to the tree map. Let's start with that, right? Like, we don't need that. We don't need that. Oops, we don't need that. That's our only get index. Okay, so that was nice. I am thinking that I want to celebrate the victory with another T. Before we continue on our simplification mission, does anyone have questions? How many T's a day do I have? Way too many. Does anyone have questions about exactly what we did here? On topic questions. Literally nobody has questions. And once again, I want to quit streaming. The stupid questions are worse than no questions, guys. All right. Yeah, literally nobody cares about what we're doing. It's fine. It's fine. Okay. So really, we have two things we could do as the next step. We could simplify these expressions, or we could do the transposition. I kind of want to break this. All right. Okay, we're going to let that cook for a little bit. Now, the only reason we can't totally simplify these expressions is because we want new size to exist, because we set it down here. That said, we kind of don't have to. Like, we don't have to keep the old size, because it's just old group fraction times the root size. An old group fraction is just fill weight total divided by root weight. So if we want to get rid of this size variable, I mean, we could recompute it here as a local instead of something that persists around the loop. Is that better? You know? Okay. Calling this root size is maybe not a good name. I mean, available, that's a longer word. That's a longer word. Maybe we should look at transposing first. The problem is the fact that we still have several variables that live outside the loop means that they all would have to transpose, right? We have root corner. We have size. We have root size. I don't know if it's worth transposing. It's like you only save like 6 lines of code by transposing and back, and it's going to cost that much. Okay, instead of passing in the root weight, which is something we don't really care about, we're just going to return the weight of how many nodes we got rid of, right? Flushed node weight. All right. And then this gets incremented by the size. Okay. And we can get rid of this. And then when we flush nodes, we'll say this is that root weight minus equals flushed node weight. Okay, and then we don't need that parameter because that was just not a thing that we needed. Okay, flush node weight minus equals C size. Type 1 at S64. Did I? What? Okay, hold on. 227. Flushed node weight is a float 64, please. Oh, I didn't do it right. Or did I make an earlier change that I also didn't do right? This is bad. Oh. Lol. Lol. Okay. So that was a good simplification. Since this is in comments in the check-in, if we ever want old tree maps back, we can get that back. I don't think we will. They're a lot worse. So is 249 lines for this whole file. That's not bad. We're not even doing anything crazy yet. So this new size.y is equal to root size.y, right? Like, you can get some parallelism here in an interesting way. See what I'm saying? Do we care about that? So this is then just a Hadamard product, right? Okay. Just make sure I didn't goof that, and then there's another step to do, right? Okay, so here, just sub width is new size.x, which is this, right? So we could swap this around and say sub width, sub height. Except, and it doesn't help me that much. Well, let's swap it around. So sub width, all right, sub height, and then new size.x is sub width, all right? And then new size.y is sub height. Okay, and then, okay. Oh God, I screwed it up. What did I, oh. Golly, brain was on autopilot. Okay, great. Now, so now instead of sub width, sub height, right? This is just like sub size. Let's call it sub. All right. And then this is sub.x, and this is sub.y. Okay. And then I think we have Hadamard product. Okay, so you'll see, like, the difference is just whether it's group or single fraction in which slot, which is kind of interesting symmetry. Sub width. So now this again, right, when we do our other aspect ratio, oh, that's literally the only time we ever do an aspect ratio. I was going to say we make a function that takes a vector too, but it doesn't matter. It's literally the only time. Okay, so is it worth making this into an operator overload Hadamard scenario? Nah. Nah, I don't think so. In fact, this is a little bit harder to understand in some sense. I don't know. Okay, here's the thing, guys. Here's what I'm thinking about for tweaking this. We're doing this divide with like the max and all this stuff. Okay? But what we really want to know is new aspect less than old aspect, right? Okay? So new aspect is, let's call it A1 over B1. Or let's call it, let's not use A because A is like aspect, right? It's like x1 over y1 is less than x0 over y0, right? Now it's a little more complicated because we're taking the max between that and the inverse. But if it wasn't more complicated, right, this is equivalent to saying x1 times y0 is less than x0 times y1, right? Which gets rid of our divide by zeros and stuff. Now, like I said, it is more complicated. So it's really max x1 over y1, y1 over x1 is less than max x0 over y0, y0 over x0. All right? That's our scenario. Oh my God, the TV is sleeping. We gotta save it. T round 2. Fight. Okay. So, how does the max come into play? Really what we want to know is see, functions like max really are not that fun algebraically. Can we do anything with this? Can this be solved using a bit shift and addition? How would you use a bit shift here? These are floating point numbers. XOR? What? You guys are trolling. You guys are trolling me right now. Maybe we should use ATAN2 for perspective projection. No offense, ATAN2 guy, wherever you are today. It's just a meme. It's become a meme. You know, I got nothing here. My only idea, since all of these are positive numbers, okay, we don't have to worry about inverting max by dealing with a negative number, right? These are all greater than 0. So we could multiply by the entire ass denominator, right? So we could go multiply by x0 times y0 times x1 times y1, right? So this becomes max x0 times y0 times x1 times x1. This is kind of interesting. X0 times y0 times, okay, well this is interesting because the x0 times y0 is going to factor out in the next step, right? Times y1 times y1 is less than max x0 times x0 times x1 times y1. Isn't it cool how you just kind of substitute one of them every time? And y0 times y0 times x1 times y1, right? So, and this becomes x0 times y0 times max of this. Oh. Uh-huh. 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 Do you see this? Do you see this? Do you see that shit right there? So you dot product the vectors, sort of. You take x squared and y squared, and you take the max of that, which is easy and doesn't involve any singularity. And then the thing is you have to multiply it by the other term, which is weird. Okay, here's what we're going to do. We're going to screenshot and we're going to open the very valuable Microsoft PBrush. And we're going to put the exact pixels. Actually, I have Photoshop and that'll do layers if it will start up today. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. When I gave a speech at my old university a little bit before the witness shipped, I did a thing where I ran Photoshop to show the irony of how it would pop up the loading splash screen that had a bitmap faster than it would pop up to a place where I could load bitmaps. Like it did that instantly in like 8 years ago. Now it takes 7 seconds to get to that point. That was instant 7 years ago. I just would like to point this out. All right. There we have a goofus. One second per year. I mean, that's some kind of Moore's law. Okay, so we're going to do this because this is what makes us better, right? Okay, so old aspect, literally what did we say here? We want this if so we're going to go A we could factor this into a function, but all right, and then we want B, which is old becomes new. What is old is new again, and what is new is old. This is kind of unreadable, but it gets rid of the divides, guys, which gets rid of instability and is faster. So if A is less than or equal to B, okay. Now, new aspect is just sub. So we can actually replace all of this in a bit. And old aspect, I should have taken the W and checked in. Okay, this is an interesting one because it's actually subject to mathematical error a little bit. I'm a little bit scared. We're going to try it out. The problem is the inequality. We might want to add an epsilon. All right. All right. Old aspect is just root size. Okay. Or no. Yeah. Okay, that really didn't work. This isn't going to help anything. I think I just goofed. Why did I goof? What did I do? So sub and old aspect, which is the root dimensions. Okay, so A, B. A, B. Does anyone see a mistake? Did I make a mistake? Shouldn't it be both new aspect and A? No. No, 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 no. That is not what the math, I mean, maybe it should, but it's not what the math says. Okay, well, I mean, it is scary that these numbers are very large, right? That is a concern. But it wouldn't be this inaccurate, right? Here's the thing. Would we fail this check anyway if we did it the old? Because the way that we structured this, we're doing something a little different. Okay, so that's 194. 228. We would have failed this check anyway. The thing is, it's the first one. Okay. So you're not allowed to fail the first one. Should I put back a first flag? I mean, we could just put the frickin' divide back. Okay, hold on. We like colon equals first, or a is less than or equal to b plus epsilon. All right? And then if we like, boy, I really trashed this function. Well, it's doing something. I should have left the old code. Okay, when you have something really dicey like this, one thing you can always do is add the new computation and do it alongside the old computation and assert that the results are always the same, right? That's not going to matter. Formula is just less than? No, the equals doesn't matter. Does epsilon even matter? It's a good point. Epsilon probably doesn't matter. It only matters if we think that the math error is preventing us from exactly matching our previous thing. I like this version in principle because we don't have to track everything, right? Like, it's one less variable because you don't care about the old aspect ratio, because old aspect ratio is actually just your previous subregion. Well, you are tracking an extra thing, but it's something that makes sense to track. It's like, here's the last frame's total region, and then here's the last frame subregion of my area within that total region. Like, that makes a lot of sense. Yeah, let's not worry about the epsilon. How hard would it be to save this off? Yeah, I mean, we might do that. This is, of course, annoying in Emacs, but we're just going to do this. And if you accidentally do something, you're very sad. Okay, this is, I think, fine. Okay, so we're back to working. Do I even want to try to make this work again? Because all we're doing is getting rid of these divides. But it is like, it is a lot stabler, right? It is a lot stabler. We did do some small cleanups. And the other thing, it is a little bit more code, honestly, right? Kill the division. I mean, it's true. It's true that lack of division is an aspect of quality software, right? It's just this looks bad, but it's actually not that bad. So here's what we're going to do. We're going to make that condition. It's counter-strike condition 0. And then this time, okay, so instead of new aspect, we're going to go sub. And at least it won't look as gross, right? And then old aspect is size, actually, right? That looks a lot less bad. And then if these were both 3 letters or 4 letters, that would be even nicer. So condition 2 is A less than or equal to B, right? That's counter-strike condition 1. So this is going to be messed up now, right? Totally messed up. Okay. Should we just trace the math out again? Initial size is 0, 1. Oh, right, we forgot, yeah, we forgot the not failing on the first one. Okay. We actually don't need to add a first. We know if unflushed index is equal to it index. Anyway, let's put first back. First is, however, going to be unflushed. Unsized cursor is equal to child index. Like that. So we don't have to worry about that goofing. Hey! Oh, wait, we said if condition 1. Oops. I got excited for a second. Hey! It's... I don't think that's the same. No, it's not. It's messed up. But it's not like massively messed up. Okay. We're going to go to Photochap. And I don't care. Stop it. We're a lot more differenter in a way that is noticeably worse. Our rectangles are longer. But we are filling out the space. It's just our decision is wrong. So here's what we could do that I'm going to regret is we go assert condition is equal to condition 2. This is how you really do this if you're programming. Wait, what? What? Why didn't that trip? Wait, did I not? Dude, I have all these windows. Okay, that's why. Okay. Condition is going to be, let me guess, condition is true and condition 2 is false. No. It's the opposite. All right. Okay. So, old aspect, new aspect. They're not very close. So that's good. It means we're not having math error. A, B. Those are also not very close. So now it could be that for some reason the aspects and the sizes desync from each other. So let's check that. So size. So there's the ratio for size. Okay, that doesn't fucking match anything. Because it's supposed to be new size, isn't it? No. Oh wait, new aspect is sub. Hold on. Old. Okay, hold on. Sub.y over sub.x. 1.71. That matches new aspect. Okay, so old aspect does not match size. That's the problem here. Old aspect is way off. One dot three. When did we get that? So if we liked it, we say old aspect is new aspect, size equals new size, continue. So is this after a flush? Let's ask. First, wait, no, unsized cursor, child index, 4. So it's not right after a flush. What? Because we say size is new size, old aspect is new aspect. Oh, shit. New aspect is sub, it's not size. This was wrong. Wait. New aspect. Okay. Yeah, no, this is stupid. This has to be old sub. I don't know why I'm using sub. These are two different things. This is an error in units if we were in physics class, sort of. Not really, because fractions don't tend to, but you know. We're comparing two different things. We're comparing the aspect ratio of the full thing to the aspect ratio of the sub piece. Really, we want an old sub. Okay? That's the deal. So I'm just going to call it old for a second. Just because it's 3 letters. That's a stupid name. Okay. We're going to say old colon equals root size. All right. And when we do this, we're going to say old equals sub. That's what we want. That is the thing that makes sense. Okay. Now we just totally fucking crash. Oh, because let's take out the assertion for a second. I mean, that looks pretty reasonable. That might be down to mathematical error, right? Let's compare that in Photoslop. I mean, dude. Okay, we're going to turn on that assertion and find out that it's when things are size 0 or something. That's the power of not dividing, guys. You don't have to divide. I wonder if we're the only squarified tree map solver that doesn't divide. It's possible. Okay. Okay, so yeah, the aspect ratio is 687 to 0.0. We're talking about very, very, very thin things. Although, we should cast these to float 64. Honestly. I'm just going to do some messy casts. We can probably get away with fewer than these. Now let's see. Yeah, it's in the same place. Wait. Why is B 0? That's what I don't get. Sub. Oh, because sub.x is 0. It's literally 0. Oh. This is where the hack of putting 1 here is causing a nonsense answer. So we're actually fine. It was the nonsense answer that was wrong. GG's. Okay, we're gonna clean this up. We're gonna not divide, but we're gonna put a comment. We're gonna be good citizens and comment. The algorithm calls for us to compare aspect ratios where the aspect ratios are each of the form max x over y, y over x, This introduces the possibility of singularities, nonsense answers in the divides, and is also slower. By doing some algebra, we turned this into purely multiplicative. Let's do C style comments here, because we're gonna redo the algebra comparison. Okay, so new aspect is less than or equal to old aspect. Rewrites as, I don't know how to explain this. Max x1 y1 y1 x1 less than or equal to max x0 y0 y0 x0. Okay. Multiply by x0 y0 x1 y1. All right. And we have x0 times y0. This, okay, and then this is x1 times x1, y1 times y1 is less than or equal to x0 times x0, y0 times y0. All right. Let's put these out by the riverside. Okay. So you really could, you could even save the 3 scalars if you wanted to. That's a little bit hinky. Hinky dinky shrinky blinky. Okay, new aspect, condition gone, old aspect. Okay, now we could try the thing. Okay. That, I feel good about that. That is a good day's work. Okay? And it's only 1:47 p.m. All right. You might be in the minority, but you preferred the division. Well, go listen to Joy Division. It is harder to understand. This is harder to understand when reading the code. So about that, but it's more robust. Okay. Yeah, it is harder to understand. I mean, the thing is, we don't even... All right. Let's try this. Because then maybe we don't need the first thing, right? So, and we'll comment that. Looks the same. That was a good idea. Chat had a good idea today, whoever that was, which was to put the 1,0 because that's, there we go. See that? Don't you wish I'd screenshotted it more perfectly? So that the pic, okay, hold on. Talk to the hand. Wait, what happened? Oh, I moved the wrong thing. Okay, there are, you see when we get down to tiny sizes that there are small differences. So it might be worth, let's actually, well, we won't be able to see anything by zooming in, right? How do we, yeah, we won't be able to see. It actually looks like, though, we're kind of fucking up a little bit when things get really long and thin. So this is a big enough difference that I'm actually concerned. Although, no, the difference might be equal to the 1 in the divide, right? That might be what we're looking at. There was no reason to believe that that other one was correct when one of the dimensions goes to 0. How do those long strips even end up in there? It's a good question. The new layer appears to show the hidden directory? What? What do you mean, show the hidden directory? Actually, okay, so number one, there's no actual reason to expect these to come out exactly the same because this includes the object files that we're compiling and all this stuff. And so we're actually taking, that's a goofball on my part. We're actually taking snapshots of different things. Oops. Yeah, I'm fired. I'm fired. Okay, we'll just, we'll use it, and if we decide that there's a bug, we can always switch back. The thing is, instead of recording the aspect ratio, we can recompute the aspect ratio because we're just recording the rectangle, right? So we can switch, if we want to do the divide, we could just do it right here with this data. Like that's all fine. So it's actually easy to switch back. Infinite aspect ratios so that we always choose the other rectangle on the first pass. Yeah, this is just going to be a lot more numerically stable. So fill aspect, we don't ever use this. So this is just going to be that. We could put these root whatevers together. That looks nicer. This is the size of our, I mean, does this need, like, we don't need that anymore. Nobody uses this. Oh, no, except we use it down here. Okay. We'll call this accepted size. When we accept a group, this is the size of the accepted rect. Accepted size is new size. We're just going to use that name here. And then it doesn't matter what accepted size is here. Oops, got to recompile. 228. Okay. Rename the old. Rename the old to what? Let's refer to the paper so that people can find it. I mean, we only read like 5 sentences out of the paper based on squarified tree maps on the paper, based on a true story by Brols, Huizing, and Van Milk. And we'll give a URL in case people want to find it. Okay. So there we go. Maybe they talk about not dividing in the paper. We didn't read most of the paper. We don't know what they say. I'm glad they put a fucking example, by the way. Most computer science papers, because they want to sound smart, would just like have 5 pages about how to do the simple thing, but describe it in very complicated words, and then they wouldn't give an example. And here, the example makes it very straightforward. This is all, we define a data type rectangle, like nobody cares. And then this is talking about like visual tweaks that it's like, oh, maybe you want to put a frame around every group or whatever. And then how do you light them? So yeah, that's basically the whole paper. I actually don't know if there's a newer paper since this, right? Anyway, it's Vij. Yeah, I was just thinking about milk though. Thanks for the correction. You see a division symbol? Well, yeah, I mean, they talked about dividing in the paper. It's just, it would have been possible that they might have said later, you could do this thing, right? Maybe I'll send them an email about this, just as a little note. Like, hey, you guys probably noticed, but blah, blah, blah. Check in. Yeah, let's take the W again. We like W's. And then we'll have some fun. I kind of want a third T. Is that bad, or should I do it? Always get the third T. Yeah. This was a good session. I mean, we had a little bit of trouble, but we made up for it with this. Cheyenne said, "Oh, should we milk it up? Is that what is being suggested? Or okay, here's the choices that we have right now. We have a frothy chai latte with lots of milk and froth, or we have hot tea plus vanilla bean ice cream. I'm kind of liking that second option, if I'm being honest. If I am being honest, I like the second option. X0 times Y0 is less than max X0 squared Y0 squared is the case where there's a 0 and X1, Y1. Yeah. Yeah, I mean, it's useful to think about that, right? Like, what does it turn into? Right, so if there's a 0 in either X1 or... It's actually X0 that has the... because it's old, that has the 0 in it. I mean, we could put 0, 0, right? It doesn't... I don't think it matters. Anyway, so if old has a 0, A just goes to 0, all right? And then B... Actually, no, because if you put 0 in both, they both go to 0, but then they're equal, so it's fine, right? But if either component of old is 0, A goes to 0, and then B is going to be greater than 0 because The other component will be greater than 0 and max, right? I mean, from the hacky version with the else one. Okay. Okay, well. Anyway, let's do this. I think it's a little bit less hacky to just make it be 0. And then here, we just, not there, there, we just do this. It's just a little bit better. Because then people don't have to be like, why is there a 1 there? Why is there a watermelon there? They don't have to ask, why is there a watermelon there? Okay? Yeah, less than or equal works with 0, 0 because if it's 0, 0, both of these, right? So if old is 0, 0, this comes out to 0, obviously, and then this comes out to 0 because both terms are 0. So A and B both become 0. So as long as there's an equal there, because of the equal sign, the equals sign is important. Okay. Please show it on the C drive. I mean, we have a lot of stuff on the C drive. Like, Sokoban has hundreds of thousands of files, but like, I hear a challenge, right? I'm actually not 100%. Let's see. Where's our, oh, it's in file. I'm actually not 100% sure that this works, but let's try it. We're asking for trouble. Okay, since we're doing this, let's take out the printing of all the files, because that's going to make it slow. All right. Also, I actually wonder, I feel like on Windows, this might be slower, because on Windows, visiting a file might give you the size. I'm not sure. Why are we still printing? Table.count now, because of that. And this. Oh, add directory node. Lol. Parent C not found. It's taken a while, but or it's infinite looping. I don't know which one it's doing. Let's try it. This is a good robustness check. We could be infinite looping like in the new thing, or we could just be taking forever to read files for some reason. Windorstat takes a while. Break all. Okay, we're still getting mod time and size. Like, I feel like you get the size in the file header, and we may just not be passing that. Still going. File path. We're just in the middle of Sokoban. We can see how fast WizTree does it, but it's not a fair comparison to do that while we are currently running the other thing. Here, let's stop this one. Oh, this is also a debug build of the program. I don't know how much that matters. Scan. That was pretty fast. So it's doing something a lot faster than what we're doing. I'm not going to worry about it that much because the reason we're doing this is not for files. Sokoban 240 gigs. Yeah, that's about right. I mean, that's double the size, right? Because the Subversion repository is basically equal in size to your actual files, roughly. So all this orange is SVN base, and then this is like actual Sokoban. And then over here, once we get here, it's like other stuff. Like this is Sokoban. This is everything else on the computer. Probably a way to read the info from the master file table that could bypass. That quite possible. Yeah, I am not remotely an expert on these APIs in Windows. That said, if there is a massively faster way to do it, we should expose that API for people to use, right? Whereas braid rectangles, they're on the D drive. Here's the compiler. Like this is the compiler right here. This is fucking Sokoban right here. Like all these are all fucking Maya files. Half of Sokoban is Maya animation files saved out. Why? Why are they so goddamn big? It's not even that many animations. Okay. Enough foofing around. This is not actually what we're doing. So it was, you know, oops. We'll keep this off. We'll keep the printing off for now. But down here, we'll just change it back to this for now. Because again, this is going to be an example program. We're not trying to launch a tool to compete with these disk Treemap tools. We are going to use this visualization for something different. And that is where the fun part comes in. Let's just get rid of all these. Where does that root size get printed? Is that in Treemap? Yeah. All right. Okay. This is pretty good. Like, in 270 lines, a lot of which are blank, we did all of this. I hate to suggest, but because the other one came out of a university, it's probably a lot longer. I don't know that. I don't have proof. It's pretty lean for what we're doing. Is there duplicated data in animations? No, I mean, what the animator told me is there's basically two types of Maya files. There's MB, which is like the binary format, which is smaller, but subject to incompatibilities when you upgrade Maya version or whatever, right? And then there's MA files, which are like, I think the A is ASCII, which are freaking gigantic, but I still don't understand how they're possibly as big as they are. Like, it's fucking banana cakes. I simply don't get it. Let's open, let's not. Maybe that would be a big sidetrack. We could do that some other time. Okay, let me make one last tea. We'll get some ice cream, and then we'll start doing a little bit of fun stuff. It can't be that hard to make a binary format that doesn't break when you update the version. No, it's not that hard. We do it every single video game we make. But Autodesk is a small indie company hiring inexperienced developers. So what are you going to do? But that said, the problem is not really ASCII versus binary, I don't think, because ASCII is not that much bigger than binary on fundamentals. So it's really like they're doing something extra, mega, super conservative. I don't even know. I don't even know what it is. Ah. It looks like all the animation files have the full rig present. Instead of referencing the rig and saving out, just that still shouldn't matter. Like, that rig shouldn't even be that big. Like, it's literally, the animation files are 50 gigabytes for some character animations that are of little guys that are 1 inch tall on the screen. Like, it's ridiculous. It's truly full-on banana cakes. Okay, here we go. We're going to go back now and we're going to go to the main file and we're going to say zoom factor is 1.0. Zoom factor max is going to be, I don't know, let's say zoom target and zoom current is 1.0. Zoom factor max is going to be, I don't know, it's 50. Who cares? Okay, so here's what we're going to do. When we get input, we're just going to continue here if it's not a key press. If it's escape, quit is true. Oh, let's do this. Okay. If it's space. Oh, you know what? We took out screenshots, dude. All right. Wheel, mouse wheel. Oh. Case.mouse wheel. Okay. Wait. We have an event for mouse wheel, but we also have key code. Okay. Event.wheel delta. I guess we send both. Hope that's not 0 because we're dividing by it. And then we're going to say factor. Let's just print what it is. I don't fucking know what that's going to be. Typical wheel delta. All right. So factor 1, factor -1. Great. So Zoom is pow 1.2 times factor. Okay? Zoom target times equals zoom. Clamp, zoom, target, 0, 1. All right? We need a current dt. All right? Now, draw one frame. We're going to say simulate. What does that do? We're going to say zoom current. We're just going to say move toward. We're going to snag our move toward from Sokoban. Zoom current to zoom targets, and I mean, we want it to be kind of proportional motion. I don't know. Let's snag our move toward. It's one of my pet functions. I use it in literally every project, except this is a refined Jedi version of move toward. All right. So let's print zoom current, and then I'll get my T. Okay. 1. Oh, the mouse wheel is backwards. Oh, shit. This is not what I want. Oh, 0 to 1. No, what am I doing? That's okay. Usually when I clamp something in a game, it's 0 to 1. Duh. It's got electrolytes. All right, so here we go. We're zooming way in. We're zooming way out. Okay, but we're not zooming way in and way out. Except that we are. Okay, because watch this shit. Well, hold on. Let's delete this now. Let's watch this shit. Let's go center colon equals vector 2 dot x1 minus x0 times 0.5, y1 minus y0. We're going to do something about center later, but okay, we're just going to not draw this for now. No, not poo. P0, 1, 2, 3. 1, 2, 3. I got to get my T. Ah! I tried to scoop out a big chunk of the ice cream and it went flying and hit my shirt and then fell down into the dishwasher and I refuse to eat that. So I'm going to eat the rest and we're just going to have to get some more ice cream after the stream today, which I'm not sad about. Any chance to go to the store and get more ice cream is pretty good. No, the ice cream does not have seed oil, according to its table of contents. Okay, P0, P1, P2, P3. Transform return P minus center times zoom current plus center. All right. Now we can't choose where we're zooming in on yet, okay? This is the flaw yet. But we're also next we want to strafe. Oh, no, you know what we want? Okay. This is actually, I want smoother transition than this. Wait. Okay. Zoom current. I don't feel like this is working right. Oh, I'm passing the wrong arguments, guys. My move toward wants the target and then the DT. That's the only problem. Yeah, I felt like it wasn't working, and I was like, okay. Okay. Okay, here we go. Okay, now it's too slow. Okay, okay. Okay, fine. I just want it to come out faster than going in, so to speak. Boom, boom, boom. I dig it. I dig it. I dig it. Can you dig it? How weird is it that John Wick 4 had an extended riff on the Warriors that didn't add anything? Like, it was so weird. Okay. Was it good? I mean, John Wick 1 is the best John Wick story-wise, but the other ones amp up the action scenes and stuff. Like, dude, the knife store fight in John Wick 3 is insane. Usually do zoom equals mix zoom target constant times delta time. Yeah, I mean, that is... I mean, it depends. It depends. Is this different? Yes, because, well, no. Yes, so the move toward that I use is different because it moves in linear units, which is stable relative to the magnitude of the values, right? But then I'm passing in proportional deltas over here anyway, so maybe it doesn't matter in this case. Do you want it like Google Maps style? I don't know what Google Maps style zooming is. Okay. Now, we need to be able to strafe, and so we're going to have some WASD, and I'm just going to copy some stuff from because I want WASD to work, and I want arrow keys to work, and oh, I have literally key info. Oh, no. I mean, if I wanted to do a really high quality version of this, maybe I should build it into the input library. All right, never mind. We're not going to straight up copy it. Okay, so yeah, oh, this also goes through the key map file. Yeah, okay. Let's do this. Okay, case W A S D north equals it dot key pressed, right? North west south east. All right. What are these called? Arrow up. Yeah. There's got to be some higher level thing that we can do that a lot of people would want to use that just does a bunch of this kind of thing all together without being like a full ass game engine. Okay, wait. Left, down, right. Okay. And these are alt. Because you don't want to press one but release the other one and have it get confused. All right. So, now when we simulate, we're going to have dir is a vector 2. And we're going to have first make a unit vector for movement direction independent of time. North is cast float. Oh, let's test bool to float. Oh, that's exciting. North or north alt, right? Dude, why am I not using multiple cursors? Okay, so dir is vector 2 dot east minus west, north minus south. All right, and then unit vector that. Okay, dir times equals current. Delta is dir times current dt divided by zoom current, and then well, like, we want to bound this a little bit. Maybe not. So this offset is just going to be, oh, we should have a speed here. This depends on what units it's in. We're going to call it 500 because this is very resolution dependent, but we're going to no check in that. We're really going to want it to be relative to the area of the screen. Okay. So when we do transform, we want, so P minus center okay, plus offset, I guess. Right? No, you want scale first. Well, no, I guess. I don't know. I'm gonna be stupid about it. We'll factor it later. I don't know. I feel like that's been running the whole time. Key pressed. Unable to parse. Oh, I missed the if statement. North. Attempt to use a value. Oh, right. I called something north that uses north. F. Feast. We're feasting minus feasting. Okay, now I goofed something. Dir times current dt. All right, fine. North, bool. Oh no! U32. Really? Why did we make that a U32? I must not have trusted in the booleans. All right, well, all about the booleans. Okay, well, it's exactly offset incorrectly. Because it's an offset, not a position. You guys can't tell, but that was, it was not what I wanted. I mean, this is one of those things where, like, are you a gamer or are you an iPad user, you know? Okay, so now we can, like, get down and inspect. You know what I'm saying? we can like really get in there. Are you moving the camera or the map? Exactly. Okay, now what? What was the reason it didn't like see? I mean, I think it just was taking too long. But it was debug build and etc. See, isn't this a lot more fun? When we started, we didn't have anything. Okay, so how far should the offset go? See, there's a conundrum here, because you don't want the offset to be in screen pixels, because the problem is what happens as soon as someone resizes the screen. You would have to convert it, which you could do, but that's error prone. So, see how the name's changing even though the cursor isn't moving because we're just cruising over it? When was the last time Microsoft made anything this responsive? Don't answer that because they haven't. 1985 didn't even happen in 1985, dude. Microsoft, this was never their strong suit. I think the whole thing is 15 lines of code. Yep, it can be pretty simple. Okay, so that's it. Like for the end of this stream, I just want to make the offset more what? More controllable and reasonable. And I mean, that's the weird thing is okay, we're just going to have it be in screen units, all right? In screen units where -1 is half the screen width. And that means we're going to clamp it, Jed clamp it. Window aspect is window height divided by if x cast float window width else 1. So again, we're avoiding dividing by 0. And this is height over width. And we're going to say clamp offset.x minus 0.5, 0.5, where -1 is the screen width. Why? So it doesn't get changed discontinuously when the window size changes. Plenty of programs have problems with that. So we're going to clamp the x there and the y to times aspect, waspect. Okay, so we're going to clamp that. And then, okay, offset in pixels equals offset.x times window width, offset.y times window height, no, times window width. I mean, well, no, times window height. Okay, you can do this different ways. Okay. And then in transform, this is offset in pixels. But then also, remember our speed, also starring Keanu Reeves, this is too high. We're going to make it like 0.7 because now it's in totally different units now. All right. Boom, clamping so we don't get lost. That's great. And zooming. I mean, we could clamp to something closer when you're zoomed in. Oh. Right, okay. So we actually, okay, I kind of don't understand what's happening here. So we're clamping incorrectly. Now, yeah, we're not even getting the same answer in X. Oh, because this is, like the offset of the corner of the screen. Do you know what I'm saying? I think. Because of when we're adding it. I think. This is what I get for just not making a transformation matrix, by the way. So P minus center. Now this wouldn't matter if I factor it in. I'm getting tired again. This is what happens when I just don't sleep well enough. I slept fine, just not enough hours, and now my brain is just too slow to want to do this. So we subtract from center. This is in pixel units, right? That's where the point is. We multiply by zoom. We re-add the center of the screen, and I think I just don't. Here's, yeah, like when I zoom in and out, I feel like maybe that shouldn't be a thing. Okay, well. Right now, because my speed is not relative. Okay, that's not right. I goofed. So here it's letting me. Okay, before we even talk about zoom, because this is zoom 1. Oh, it's about right. It's symmetric. Let's put it that way. Guys, I've done so much today. Why is my brain stuck on this? I think it's actually kind of fine. It's just that for some reason we don't. Okay, so see here, we pretty much zoom in. So it's not exactly centered because we're zooming in by a half a screen, and at zoom equals 1, there's like a border, right? So we're seeing that. Oh, no, but we're way more on the left. What's going on? What's going on? What's going on, people? So our zoom point is here, roughly in the middle, right? See that? The thing is staying here. Yeah, we're like... I should just write the transformation matrix, dude. My brain is shutting down. Okay, it's a 2x2 transformation matrix. We're not even doing rotation. It's easy, right? It's a uniform scale. That's trivial, dude. All right? So the P, well, this minus center wouldn't even be in the, this is kind of, it's kind of emulating object space coordinates, to be honest. We could, if we wanted to, we're sort of generating this whole thing at screen space scale. We could generate it at unit scale. I'm not sure I love that idea, but we could do it. I mean, I feel like we're going to do this. It's a little bit weird because we're emulating object space coordinates, which is the way I think about it. I feel like in my heart. Okay, now we're simply not panning at all. I don't understand. Programming by guessing. Yeah, I do it sometimes though. I have to admit, I do programming by guessing sometimes, and it's not very good. But I have, and then usually I go back later and go like, really, why was that a thing? Okay, if we just imagine P minus center is the object space coordinates, right? So then we scale those. We add the origin coordinates, right? Or the location of the object. It's embarrassing to be stuck for 20 minutes on like a trivial ass thing like this, by the way. But I'm showing you what it's like. See what I'm doing, it's just weird enough that it's not what I usually do. Like what I usually do, I don't have to think about it all. Like you do stuff in 3D, it's like you've got stuff in object space, you rotate it, you scale it, whatever, you transform it, you're good. Here, like, the scale is sort of on the camera, which usually if you do that in 3D, you think about that as an FOV kind of a thing. Like I kind of want to do this, but this is not, like that's just going to negate the subtraction, right? Well, maybe not. Maybe it's exactly correct. Well, I mean, yeah. Okay. Yeah, I mean the thing right, oh, no, it's not, still not correct. Okay. Gave up and just did transfer. I mean, we could literally make a matrix 2, right? And do it. It would actually be faster to make the matrix 2 anyway. Except it would have to be, because it's got a translation component. It would have to be a 3x3 homogeneous matrix, right? Do you want it? Should we do that for entertainment value since I'm flailing so bad mentally? Let's go. Right? Oh yeah, it's here. Matrix 3. All right. So, relative is matrix 3 identity. Okay, but relative dot 1, 3 is minus center dot x, because we're subtracting ourselves relative. So this is 2 relative, right? And dot 2, 3. This is better anyway because it's more general. It's, yeah, I don't know. Okay. However, we want to put it outside the loop. We want to make the matrix outside the loop. That's part of what makes it faster. Okay, so now to scale is going to be matrix 3 identity. Scale dot 1, 1 equals what's it called? Zoom current. Scale dot 2, 2 is zoom current. All right. So that's our scale matrix. And now we need to add back. We need to go to world, right? And I capitalize these for some reason. To world dot 1, 3 equals, and this is the weird thing. All right, now T is 2 world times scale times 2 relative. All right, and then now the thing is, this is homogeneous. I don't think we have a frickin' times for this. A matrix 3 vector 2, 2, 2. I mean, we really only need matrix 3 by 2, right? It doesn't have to be a matrix 3, 3, but nobody ever does this, so there is no matrix 3 by 2. Right? So okay, so these are vector 3s. And then okay. Operator times P2 plus equals node dot size. Oh. Okay. Literally nothing is happening right now. Great. Great. Why not? Oh, because I commented out all this. That's why. Okay, well, our offset is in a different place for some reason. We are also, okay. This is an important point, is that now I think we're always zooming, like, let's ignore the 2 worlds, or let's just make that an identity for a second, all right? So now I can't strafe. when I zoom, I'm zooming in on the corner, right? But the corner's down there. So what we actually want is to add back, oh, we didn't do that part. We forgot that part. Okay, here we go. We're in the middle. We're zooming in the middle. This is exactly where we started like 1 hour ago? I don't know. All right. So, I mean, it seems right now. So there's just like some cross terms that, oh no, it's not right. Okay, here we go. Because if I'm zoomed in this far, right? See this? So it's like basically the same problem as we had. But at least we have a different way of conceptualizing it now, right? Because this is like the world space. Okay. Here's, I'm putting the scale maybe not where we want it, guys. Because this is camera scale, I'm acting like it's object scale, right? And that's maybe part of the confusion. So if we put scale here, that's scale on the camera. All right. Okay, so now we actually don't, we don't want this to be there, I think. Okay, so I'm moving around. It looks good. Okay, well, we're going pretty far outside. But that's just the regular fuck, it doesn't go to the right. Dude, what is my problem? What is happening? See, here we're going to the right, but as we zoom, oh, because to do camera scale, you subtract off the camera position, guys, right? I mean, this is kind of fucking stupid, but this happens to be the same thing. I think because we're subtracting off. Okay, it's obviously totally wrong. Guys, we're just going to cut this part of the video because it's a fucking disaster. Maybe render or dump. No, dumping the offset is not going to help because I know what it is. It's fine. Yeah, my brain is tired. So, you know, sometimes you just look at a thing and you're like, oh, I know what the problem is. And when I get tired like this, like I am today, those just don't happen in a snap like that. And that can save you like 2 hours of debugging time, you know, in the best case. Okay, so this offset in pixels is, okay, here's the thing, guys. Multiple issues going on here. Multiple fucking issues. Okay, this is offset in pixels of the unzoomed thing. Maybe we should change the variable name to be offset in pixels of the unzoomed thing, right? Scale should be in the middle. That's where we had it. We had it in the middle because we were treating it like an object space scale. Shouldn't have had the third T. I know. We burned out on everything. Okay, so obviously, well, I don't know. I don't know what's obvious and what's not. This is like, dude, it's like I'm in third grade and I don't understand anything. See, that's too much. I mean, okay, is it an object scale or is it a camera scale? If it's an object scale, it goes there. If it's a camera scale, it goes on the outside, and we need another like offset for it, right? Like we're back to this again, which is like kind of correct on the left, but not the bottom. Well, no, maybe it is correct on the bottom for what I'm doing. See, that's already off. Now it's like way off. I can't go up anymore. Like I'm computing the offset in screen pixels. All right. That's what this is. So let's put that in its own matrix, all right? All right. So offset dot 1,3 is off.x. Offset dot 2,3 is off.y. All right. But this is not times, that's just that. All right. So we go to relative coordinates. We don't, no, maybe we, I don't think this is going to fix anything. Oh. Oh. So what you want to see, another way to say what we want to see is that if there's some point, if you imagine one of the gamer reticles, maybe we should draw a gamer reticle. It should zoom in on the fucking gamer reticle, and it's not doing that. Like, what's in the middle of the screen? It's like something around where the cursor is, right? And I zoom in, and we're zooming in down there. Why? I need to go to bed, guys. This is fucking terrible. I mean, if this were open source, they would have shipped it. It's fine. Seems like I have the offset subtracted twice. No. I think it's the two world. I think I'm confusing myself. Is this the bool that I casted to float? No, we didn't do that, actually. But that part works anyway. That part is fine. What's not fine... I mean, it's pretty close. Like, this is actually usable. It's just... not zooming in on the right place, which is ass. Oh! Right. Of course it's not zooming in on the right place. I mean, okay, this might be wrong. No, the offset... has to be there. Bro. Hold on. Hold on. Sign error, maybe. Hey, look at that. Nope. Nope. It seems right when I'm hanging out over here. No, that's not right. Fuck. Guys, I'm going to take a break. This is horrible. This is a stupid disaster, and it's a waste of everybody's time. Oh, this is a good point, by the way. These coordinates for the center are wrong. That's silly. That is not so wrong that it's going to cause a disaster, but oh my God. That might have been, guys, that might have actually been the problem. Okay, if I'm being honest. I mean, now we've messed up everything else, but the center being wrong like that, chat actually said something good that the center was wrong because I just typed it without thinking. This seems good now, guys. I'm zooming into the actual center, I think. Let's see. It's like there-ish. Look at that. It's like, where's the center? It's like there. Yeah, yeah. Okay. I'm sorry for that hour of flailing over something stupid. All it was the center was wrong. And that was, so the thing is, even if it's off by only a little bit, when you like zoom a ton, it's off in unzoomed pixels, so it just becomes huge, right? Chat's been good lately. Dude, so that's exactly the kind of thing where if I'm not tired, I have a much higher chance of noticing that, right? Oh my God. I just didn't even look at that line because I was like, it's so simple, right? Okay. Well, rip my sanity. That's sad, but we got it. We got it eventually. I'll decide later whether to put that on YouTube or not. It's probably not worth it. So now one thing is when we go to like max zoom, we're not letting us go far enough. I'm not sure why that, let's fix that part. So our aspect is window height divided by window width, all right? And then we're clamping the Y offset to 0.5 times aspect, which maybe isn't right. No, you just want 0.5. See, the thing is, I want it in, the reason I'm doing that is because I want uniform speed in X and Y. So I don't want X and Y to be at different scales. I don't want X to be at window width scale and Y to be at window height scale, right? I bet this is window width here. I bet I goofballed. All right, all right. Yeah, I goofballed. Okay, so this is maybe a little bit much, but it's because of that. It's because, you know, when you started in the beginning, there's this border, and then if you zoom in a bunch, you're just seeing the border, right? So what we really want to do, instead of window width, window height, we're going to have like an aperture that's like aperture science, and that's what you'll see the thing. It'll be the width and the height of that, right? And then you zoom around within the aperture science. and probably we scissor. And then this won't happen where you get outside. See, so now I'm at the maximum top. See how wide that is down there? I go to maximum bottom. It was just at the center. Oh, it's so embarrassing, guys. Although it's not embarrassing. The embarrassing thing is that I sat there and flailed just trying random stuff. It's not a very good way to program. I do that when I get tired. Sometimes, not always. Anyway, this is a good stopping point, I think. Next time, I think next time is the time, which might be tonight, it might be tomorrow, depending on how tired I am. I think we want to do the thing where we actually visualize program data with this. All right? So we're going to have, the root is like the program, and then we're going to have all the modules, okay? And then we're going to have you know, the functions inside the modules and stuff. And if we do this at compile time, we don't even have to serialize yet. Although we probably have a lot of the data, but maybe not all of it. Now the problem is, guys, last I checked, Simp didn't run at compile time. For some reason now, choose pixel format fucking crashes when we run at compile time. So, why? Add rotations first? No. No. But what the hell is this? Like, why is choose pixel format fucking crashing? Like, that's... It didn't used to. Just to give us a little leg up on next time, we'll go take a look at this for a second. Actually, first we'll take the W. See, it was a hard-earned W. I tell you what, it was supposed to be quick and fast, took an extra hour or something. Oops. Scaling and translating have been added to Treemap. Boom. Okay, so we can add camera shake. Why is choose pixel format being a jerk? This is something I would like to fix for the beta users anyway, but it's off topic from my fun weekend project, which suddenly became not very fun in the past hour. Dude. Okay. I mean, we're calling wgl adjust pixel format. I don't think there's anything wrong with the pixel format. I think it's going to be... I printed out the HDC and all that before. It was right last time I... I spent like 20 minutes making sure the windows and the DCs and all that were right. Okay. Pixel format descriptor, size 48, version 1. Maybe the size is wrong, honestly. Pixel type 0, color bits. You know what? Let's compare this to running at runtime. So the DC is totally different, but that doesn't matter. Oh, version is different. No, it's not. Flags 37, pixel type 0, flags 37, color bits 24. Zeros for the whole rest of the struct. Zeros for the whole rest of the struct. Struct seems different. How does it seem different? It's true. The spacing is different because the HDC is a different number of digits. All right, that's the difference. Because here it's just, it's got 16 fewer digits. Now, does that matter? Like if I run at runtime, no, see, there it's not a negative. So the HDC is just, it is what it is. Sometimes it's negative, sometimes it's not. Nobody seems to care. Is it maybe a similar issue to the Linux crash? Loading, linking to the wrong lib file. There is no... What people were saying in Linux, there were lib files. Like, where are they talking about? Am I on Windows 11? Yes. In X11. Oh. Yeah, I don't know why that's there. I don't know why we think we can ship an X11 lib. That does not make sense to me. Like, that obviously is going to be incompatible with whatever the hell is on people's systems, sort of. Maybe. I don't know. Is the HDC supposed to be unaligned? You thought it was an opaque pointer to something Windows internal. What do you mean unaligned? It's the first thing in the struct. That's a thing we could do, though, is we could print the address of the PFD. Does the pixel format descriptor have to be aligned? Okay, wait. So that's aligned to 64 bytes. Maybe it's not here. It is not. Does that doesn't have to be aligned though, right? You're also loading GLX, whatever. Yeah, if someone wants to email me what the hell is the right Linux thing to do, I think that was a mistaken thing that someone working on the compiler was doing a long time ago. They misunderstood what I was saying that we needed to do. You know, but we want to be able to build things that frickin' run, right? So, I don't know. Anyway. This is not very fun, and I kind of don't want to do it. I mean, the question is, does pixel format descriptor, does like Visual Studio align this on the stack? For some reason. Let's try this. This is an easy way to align it. Address. That, where are we? Yeah, so that it is now aligned. And that didn't matter at all. I wonder if we're calling something in the compiler now that is upsetting the graphics driver in some way. Can I get the Windows log? I don't know how any of that stuff works. If somebody does, they can tell me. It's happening in set render target. Like choose fixed pixel format is such a weird place to crash. Like, this is exactly the kind of thing. This is, after having just wasted an hour on stupid math, even that is not as bad as this. This is the kind of thing that happens all over the place and wastes weeks and months and years of programmers' lives. Because, like, what's happening? How do I find out? Why? Like, I don't know. I don't have traction here, right? Open Event Viewer. All right. Event Viewer. Navigate to Windows Logs Application. And look for exclamation points. We have gup date. I don't see any exclamation points. We just have gup date. Is the function pointer to choose pixel format valid? The stack says it's choose pixel format. It doesn't say null or unknown location. It says choose pixel format. Have to manually refresh, but it would have had it when we opened it, guys. I just hit F5 a bunch of times. Printing out HDC gives an unaligned value. HDC is just something that Windows gave us. We didn't allocate it, right? So HDC has an E, it has an F. So those are obviously not aligned, right? All right, so now if we go here, well, that's 4 byte aligned at least. Did we get lucky? No, it's not aligned. Not aligned. Not aligned. Not aligned. Yeah. No, it doesn't. Alignment is not a thing for that. Try using describe pixel format. I mean, yeah, we do that. No, that's for a pixel format. That's not, that gives us a pixel format descriptor, dude. What if I just ignore this? No, because we need the describe pixel format goes the other way, right? People on the internet are saying it's possible get proc address gives you the wrong choose pixel. Oh. Well, that would then, if there is a choose pixel format that's wrong, I don't think we get it from get proc address. Oh, wait. Wiggle choose pixel format ARB. What if we call this instead? Oh man, I would have to like do all this crap. Let me see this link to see what is being talked about. We all know Stack Overflow knows all the things. Trying to create a simple OpenGL, crashes and choose pixel format. Code used to work a while back, but for some reason doesn't work anymore. It's exactly. Did you get address of function? Faulty drivers can cause crash in this too. Choose pixel format may be implemented and explored. Might not be. Yeah, we don't. I don't believe we get it that way. Yeah, no. This is This is not. This is Stack Overflow. This is Stack Overflow being Stack Overflow. This is pretty much a null pointer dereference here. I guess we don't know. We don't know exactly what the exception is, do we? Let's. I mean, I don't want to use this wiggle choose pixel format, but like, I kind of don't know why we're doing it two different ways. Do we have this loaded? No, 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 compile, please. Okay. That is only exists locally. This is silly. Didn't even paste the right thing. Now this is weird. Why is it giving us, maybe I should have looked at this. I meant API, but okay. HDC pixel format descriptor pointer. Why are people telling me to call describe? Guys, describe pixel, this is a different thing. All right, here's what I'm gonna do. We're gonna do some crap here. We're gonna do like literally, see, we're calling this and then returning and doing this, and so we do these attributes and we do all this crap, like mega crap. See, this choose pixel format is only so that we can boot an OpenGL context anyway. Yeah, we could run the compiler in the debugger if we want. I just wanted to try this first. I hate everything about what I'm looking at right now, by the way. Literally everything I hate. Let's just call it. Can we call it? So that's crashing also. Okay. Just, it was a thing that we did. All right. Now we're crashing in choose pixel format. Let's run the compiler. Shut up. What are we running it on? Treemap build. Okay. I should run debug compiler. I don't know why I'm in release. Shut up, shut up. It just, Visual Studio has this way of like popping up too many windows when something goes wrong. It's like, dude, I know it went wrong. Just shut up and let me work. And it doesn't. All right, so debug build compiler, etc. Misspelled pixel instead of pixel. What? Was? But I just copy pasted that. Pinixel. Did I just typo? I might have typoed that. Yeah, I must have control end in the middle. Well, that would explain, because this print would have printed null. All right, you know what? Let's before we go do this, let's just see what this does. This was from before. Still crashes there. It's null. Okay. Maybe we can't query this. I feel like the reason we weren't calling this, because that was a question that I had, is that you can't actually successfully query it. You can't call wiggle get proc address until you have a base OpenGL bullshit context, right? It's such a disaster. Okay, so we're back here. Let's double check the name to make sure I didn't like double misspell it. WGL choose pixel. Yeah, I think it just doesn't work. This is the OpenGL Bootstrap context summer intern open source extravaganza. Okay, so this is in dyn call, which is, you know, it's a thing that we do. It's possible that we're calling this wrong, but we call other things. I don't know. Let's look at, see, what the fuck does external code mean? Is this, okay, so like, is this even error reading register? I can't read the register. What are you talking about? I mean, it would have been hosed by calling debug break anyway. Maybe that's why. Oh, that's why. So this is literally in DC call. I guess it won't let us look at it because it's the driver. But that's just going to be a pointer to the procedure. So we don't get any visibility into the crash, is what we're saying. It's 100% calling the wrong thing? How do you know? How do you know? It runs for you at compile time, so something else is going on. Yeah, it used to run for me at compile time too. There aren't any 32-bit numbers being passed to choose pixel format. It's the return value. DC call long is for something with the return value being a long, all right? Can you look at which DLL the crash and get? No, I can't. What do you want me to do? I don't even... Visual Studio's not even giving me the stack address of the goddamn thing. How am I supposed to do anything? We could... Okay, here's what we could do. Oh, guys. Oh, shit. We had a bug before because our exception handler that we set up in order to give people good reports at compile time was like overzealous and caught some weird exception that was being used by someone weird, right? What if the GL driver is sending itself bullshit exceptions to do things and we're intercepting it? What do you think the probability of that is? I think it's quite high. I think it's quite high. I don't know why I didn't think of this to begin with. 42%? I think it's 60%. How do I do my thing? What are my... How do I do my... Yeah, that's it. How do I do... There we go. That's... All right, I'm gonna get an iced tea and then we're gonna look at this because I feel good about this possibility, although I don't, but I do. There's a Handmade Hero video where Casey fought Wiggle Juice Pixel Format ARB. I don't know if that's going to be related to what we're doing or not. Like this is literally vanilla choose pixel format, but maybe it's calling into the driver. Okay, so when we do this again, we're in handle exception. P exception info. Yeah, we don't seem to be... Where do we set this up? Add vectored exception handler. I don't know if there's something we're supposed to do about this. Okay, so exception record, exception code, exception information. Oh boy, that's a lot of really great information right there. How are you supposed to filter exceptions? Okay, here's what we're going to do. We're just going to return. Okay. Didn't matter. Although we called our exception handler. What? That must be the Linux function that I'm looking at. Oh, wait. Oh, this is the release compiler. We ran the wrong one. Okay. For some reason, we can't load fonts now. Are we setting the working directory to something? What is going on? Set working directory. Oh, get path of running executable. Yes, yes, yes. What is the directive? Compile time, right? Like, I made it, I should know. Okay, so this is the same thing. Like in the simp demo, when we got past this, we had this other crash, all right? So, this is something where we want to figure out a better policy of what to do. So there we go. Okay. So now, instead of turning off the crash handler, okay, we want to only set it Yeah, so this is the thing, is some drivers want to send themselves an exception, or I don't know what's happening. Interactive. Oh, I didn't. This is not the way. Interactive 0, that's what I thought. Okay, so set error mode. No guppy fault error box. No open file error box. These don't have anything to do with fucking anything. We have to use, okay, Raphael changed this last year. We have to use a vector exception handler because ladder requires them being able to, okay, how, okay, so I don't know anything about how these work. Add vectored exception handler. Let's make it be last. The last shall be first and the first shall be last. There we go. I mean, that's one way to do it because we let other people handle it. And then, so the thing is, we're always barfing. Yeah, all right. Why are computers like this? Like why are we sending exceptions to get, all we're asking is what pixel format do you want me to use to even start the API so we could talk about rendering things? Why does that send an exception to anyone? Right? Like what NVIDIA employee did that is what I want to know. Or Windows employee. I don't know. I don't know whose fault it is. Could be Tim Apple sent a spy. Okay, this is in the debug compiler running at compile time, everybody. Let's do that in the release compiler, at least. Okay, that's a W though, because that's actual value for the people. All right, so now we are running at compile time. Why did I want to run this at compile time? Oh, because now we can do this when we compile Sokoban, right? We can make this into a plugin. We could pop it open and like that. Okay. So that's going to be next time. We'll probably do it tonight. Dude, that 1 extra hour of the center being wrong really took some energy out of me. So we'll see how it goes. But thank you for coming by. And 1 extra hour is nothing. I mean, this is still very high productivity, right? Like, this is stream number 3. And we have a Treemap Viewer that works. And we made an improvement in the base algorithm. And we could pan it around. And, you know, we hadn't even started this yesterday. So that's all pretty good. So yeah, the next step is retarget this to the program. And then I don't know. It's going to be a little weird because I want to keep this as a standalone example for, you know, directory files, right? Just because that's something everybody understands. And it's like, hey, this is a Cheezo version of WizTree. And you could imagine, you can easily imagine how to make this look nicer and, I don't know, figure out how to get the data faster and all that stuff. Yeah, I bet what you do is you just, there's probably something to query an entire folder, which we honestly should look into for other reasons. Because when Sokoban starts up, we actually do an operation like this on the data folder. And if we could make that go a lot faster, that would be great. I mean, it goes pretty fast, but it could go faster. Would there be a way to make it as fast as WizTree? I mean, obviously there's some way to make it as fast as WizTree. It is clearly possible. I just don't know what WizTree does. Invite Vlad2305M to the secret beta. I mean, sure. If you wanna whisper him and tell him the instructions of where to email, that would be cool. WizTree reads the NTFS directly. Oh, that might be a little bit spicy. That might be a little bit spicy. What will be the benefits of using this compared to WizTree? None. That's not what we're doing. We're not making a WizTree competitor. We are making a Treemap library and we're using folder data as validation for that. Remember to delete all the crap from choose pixel format. I believe I did. Let's go double check for no check-ins and yeah, I don't see any. Yeah, I deleted all the extra WGL choose whatever. This is what I copied it from. Such a disaster, dude. And then the web GPU wieners decided they needed a totally different syntax for their shading language that's exactly the same as every other shading language. But it doesn't look like Rust, so we have to make it look like Rust. It's all so embarrassing, everybody. Okay. Yeah, I'm going to go out into the world because I haven't done that today, and maybe get some dinner, and we'll see. We might do another installment tonight. We might do one tomorrow. It depends. Ice cream run. Oh, that's an idea. Let's take the W before we forget. Okay, so now we know we can do this at compile time. That's fine. Commit. Improvements. Okay. Thanks, everybody. See you all later.